Hello everyone, and today we are going to discuss about the differences of uranium and thorium mainly in nuclear reactor. First of all, let's start with the introduction. Martin Kaprot, a German chemist, found uranium in the mineral pitchblende in 1789. It was named after Uranus, an 8-year-old planet that had been discovered. Uranium is thought to have created some 6.6 billion years ago in supernova. While it is not widespread in the solar system, it is now the primary source of heat inside the Earth, inducing convection and continental drift. Because of its high density, uranium is also used in yacht kills and counterweight for aviation control surface, as well as for radiation shielding. The melting point of uranium is 1132 Celsius. Uranium has the chemical symbol of U. Meanwhile, thorium, with the symbol Th and atomic number 19, is a naturally occurring radioactive chemical element. Thorium is a delicate silvery white metal that tarnishes slowly because of its stable. John Jacob Berzelius, a Swedish scientist, discovered thorium in 1828. Thor, the Norse god of thunder, inspired the element's name. Gerhard Schmidt discovered thorium was radioactive in 1898, and Marie Curie exploited it in her famous study on radioactivity. Because of its lengthy half-life, nearly all of Earth's thorium is thorium-232, which is the weakly radioactive, which has the half-life of 14.5 billion years.
There are some comparisons of nuclear components between uranium-fueled nuclear reactor and thorium-fueled nuclear reactor from size, fuel, moderator, fission rate and heat produced, cost, source abundance, and experience. First and foremost, about the size of the reactors between uranium and thorium, what will be the difference? It is basically shifting the fuel element from enriched uranium to thorium combined with uranium fuel from plant to plant. This means replacing the fuel element will not enlarge the size of the nuclear power plant by a factor of 1.5 times, while only making the nuclear reactor section slightly bigger or smaller. The balance of nuclear islands, which usually occupy most of the space, is unaffected. For the operating system part, it does share the same operating system. However, thorium-fueled is more recommended to be built inside a molten salt reactor, as normal fabrication of fuel can be avoided. Apart from that, talking about fuel, for a normal uranium-fueled nuclear reactor, it will be enriched uranium-235 combined with uranium-238. They fit into a small pellet and the pellet will fit into a long rod, which is called a fuel rod, and then pack it into assembly. For thorium-fueled nuclear reactor, thorium-222 will combine with uranium-233 to act as a fuel, as thorium is not a fissile material but a fertile material. Thorium will be first purified, then converted into a fluoride. The same initial fuel loading of 1 ton per year is discharged primarily as fission product to be disposed for the fission thorium cycle. Ease of separation of the lower volume and short-life fission products for eventual disposal. Moreover, thorium-fueled nuclear reactor, to be precise, uranium-233 fueled nuclear reactor will share the same moderator as uranium-235 fueled nuclear reactor, as they both have higher cross-sectional area for fission for thermal neutron, where uranium-233 have the value of 531.3 Bern at 0.0253 electron volt. Therefore, sharing the same medium of moderator will not be a problem, but a merit for thorium reactor to be used in future. Aside from that, comparing fission rate and heat produced, 1 ton of thorium can produce as much energy as 35 tons of uranium in a liquid fluoride thorium reactor. Conventional reactor utilize less than 1% of uranium. A well-working reprocessing reactor can utilize 99% of its thorium fuel. However, when comparing breeder reactor for uranium and thorium, the energy per kilogram will be similar. 1 ton of natural thorium-232, not requiring enrichment, is needed to power a 1000 megawatt electric reactor per year, compared with about 33 tons of uranium solid fuel to produce the same amount of power. Furthermore, thorium costs only $30 per kg and gets cheaper and cheaper due to its abundance on the crust of Earth, while uranium future fell to $45.05 per pound, which is around $99 per kg at the end of January. For a typical 1000 megawatt electric reactor, fuel cost for uranium is usually worth up to 40 million, 18 months fuel cycle, replacing 1/3 of the core. In this case, thorium are roughly to estimate 1/4 of the price. Assume that the production of fuel will be the same, as it should be much cheaper. However, it could be more costly on the handling of fuel and reprocessing, as thorium-222 fuel will produce waste with gamma ray with high energy. Other than that, thorium is 3.3 times as abundant as uranium, almost matching the amount of lead and gallium in the Earth's crust. Thorium composes 0.0006% of the Earth's crust, while uranium composes 0.00018% of the Earth's crust, where a substantial amount of uranium is found in dissolved seawater. The Thorium Energy Alliance estimate there is enough thorium in the United States alone to power the country at its current energy level for over 1000 years. Last but not least, thorium-fueled nuclear reactor is only in the experimental stage. Research and development of thorium-based nuclear reactor, primarily the liquid fluoride thorium reactor (MSR) design, has been or is now being done in several countries such as United States, United Kingdom, Germany, Brazil, India, China, and other countries. At the same time, uranium-fueled nuclear reactors are commercialized use until now. Uranium was discovered in 1789 by a German chemist. In 1939, a team of French scientists demonstrated that fission can cause a chain reaction and filed the first patent on nuclear reactor. Later in 1942, a group of scientists set off the first nuclear chain reaction through the Chicago Pile 1. Interestingly, they built this makeshift reactor using graphite bricks on an abandoned squash court in the University of Chicago. These experiments proved that uranium could produce energy through fission. Uranium is now used to power commercial nuclear reactors that produce electricity and to produce isotopes used for medical, industrial, and defense purposes around the world.
Similarities between uranium and thorium reactor. Both reactors are fission reactors. That means both reactor undergoes the nuclear fission reaction. Nuclear fission is a reaction in which the nucleus of an atom splits into two or more smaller nuclei. In the fission process, a large quantity of energy is released, radioactive products are formed, and several neutrons are emitted. The fission reaction involved in a uranium-fueled nuclear reactor and thorium-fueled reactor are as follows. Besides, heavy water reactor, pressurized water reactor, boiling water reactor, and fast neutron reactors can be both be used as uranium-fueled and also thorium-fueled reactors.
So in this part, we're going to discuss about advantage of thorium-fueled nuclear reactor by comparing it with the uranium-fueled nuclear reactor. For the first advantage of thorium-fueled nuclear reactor is that thorium can be considered more abundant than uranium. Thorium is 3 times as abundant as uranium and nearly as abundant as lead and gallium in the Earth's crust. Estimate that resources of thorium across the world was 6.2 million of tons. we can know that almost all the thorium is fertile thorium-232 compared to uranium that is composed of 99.3% fertile uranium-238 and 0.7% more variable fissile uranium-235. After that, the second advantage of thorium-fueled nuclear reactor is that thorium produces lesser nuclear waste. From this we can know that there is much less nuclear waste when thorium is used as a fuel in a liquid fluoride thorium reactor. From the statement from Moore and Teller, it eliminates the need for large-scale or long-term storage as it avoids the need to have a huge storage facility. Hazardous waste will be also 1,000 times less than uranium, and the radioactivity of the resulting waste will also drop to the safe level. On the other hand, the third advantage of using thorium-fueled nuclear reactor is that the management of spent fuel for using the thorium reactor is cheaper than the uranium reactor. Since all the natural thoriums can be used as fuel, hence there is no expensive fuel arrangement is needed, and for the management of spent fuel can save a lot of cost for the thorium reactor. So according to European Organization for Nuclear Research, it estimates that 1 ton of thorium can produce as much energy as 200 tons of uranium or 3,500,000 tons of coal. So according again to Moore and Teller, once a breeding reactor is started, it needs no other fuel except thorium because a breeding reactor makes most of all of its own fuel. The fourth of the advantage for the thorium-fueled nuclear reactor is that the way to obtain thorium is more safe and more efficient. As we know, thorium ore generally contains higher concentrations of thorium and comprises significant amounts of thorium than the percentage of uranium found in its respective ore. So this makes thorium a more cost-efficient and less environmentally damaged fuel sources, as it's able to let the element's extraction cost-effective without resulting a serious impact on the environment. Whereas the process of mining the thorium is easier and less dangerous than uranium mining. This is because the mining process for thorium is an open pit which requires no ventilation, but unlike the underground uranium minings, where radiation levels can be potentially harmful.
No matter how amazing thorium-fueled nuclear reactor sounds, like everything else in the world, there are also a few disadvantages that needs to be considered during decision making. First and foremost, a thorium-fueled nuclear reactor has an extremely high startup cost, which means that a big sum of money needs to be invested initially. This is due to the fact that there are still a lot that is still unknown regarding the operational experience with thorium. Tests will be needed to be run, and the workers will be needed to analyze it. More so, even after all of the testings and all of the money spent, there is still an uncertainty whether the money invested will be returned, therefore making it risky to just dive in blindly into building a thorium-fueled reactor. Other than that, thorium as a fuel will also cause the cost of fuel fabrication and reprocessing to increase compared to a normal fuel. Besides the obviously risky investment, the preparation of thorium fuel is also very difficult. In order to produce a high quality solid fuel, extreme heat is needed to reach the high melting point of thorium dioxide. It is known that thorium oxide has a higher boiling point than uranium oxide, with the difference exceeding 500 degrees. The high temperature is needed to make high density thorium oxide and thorium oxide based mixed oxide fuels. Moreover, unless a fluid-fueled reactor is built, the inert property of thorium will be a problem since it will be difficult for the thorium to be chemically processed. The last disadvantage of a thorium-fueled nuclear reactor that will be discussed is that there is a significant amount of gamma ray emission in the short term from the irradiated thorium. This is caused from the large amount of uranium-232 in the irradiated thorium produced from the decay chain. These gamma rays are high penetrating, which makes them very hard to be shielded from. To avoid excessive radiation exposure to its surrounding and workers, a costly investment must be made for a safer fuel handling and reprocessing by buying the proper equipment needed and so on. This will add up to the overall already expensive bill and will for sure deter most people away from investing in a thorium-fueled nuclear reactor.
Hello there! I'm Rashman, son of Jayanathan, and I will be explaining the advantages that a uranium-powered reactor have over a thorium-powered reactor. First of all, a significant amount of experience has already been garnered in operating uranium-powered reactors. We don't have as much experience with the metal thorium itself, let alone thorium-powered reactors. The nuclear industry is quite conservative, and the biggest problem with thorium is that we are seriously lacking in operational experience with it. When an astronomical amount of money is at stake, it's difficult to get people, especially the authorities, to change from the norm. Other than the experience factor, uranium-powered reactors also boast an easier process of fuel preparation. Thorium fuel is a bit harder to prepare because thorium dioxide melts at a temperature that's over 550 degrees Celsius, higher than that of uranium dioxides. Such a high melting point means a lot more energy is required to produce high-quality solid thorium fuel compared to the traditional uranium fuel. Additionally, thorium is also quite inert, making it all the more difficult to chemically process. Uranium fuel pellets also possess lower radioactivity when irradiated compared to thorium. Irradiated thorium is more dangerously radioactive in the short term. The thorium-uranium cycle invariably produces some uranium-232, which decays to thallium-208, which has a 2.6 megaelectron-volt gamma-ray decay mode. The bismuth-212 decay pathway also causes problems, as these gamma rays are very hard to shield, making the process of handling and/or reprocessing spent fuel more expensive and difficult than it already is. Last but not least, uranium-powered reactor is available in the fast reactor option. This is because thorium doesn't work as well as uranium-plutonium is in a fast reactor. While uranium-233 is an excellent fuel in the slow neutron regime, it is between uranium-235 and plutonium-239 in the fast spectrum. So for reactors that require excellent neutron economy, such as breed and burn concepts, thorium is not an ideal fuel.
To expand even more on our discussion, we will explore the disadvantages that lies within uranium-fueled nuclear reactor. The first disadvantage that we will talk about are the renewability of uranium fuel. As its name suggests, uranium-fueled nuclear reactor use uranium as its source of energy. The amount of uranium that we could get are finite. During 2009, Nuclear Energy Agency (NEA) has estimated that the accessible uranium sources could run about 200 years at the current rates of the consumption. When it was calculated, the amount of nuclear reactors that use uranium as its fuel has increased exponentially after the calculation was conducted. So it's safe to assume that uranium will be depleted a lot sooner as its consumption rate has increases. The second disadvantages that can be found are in the mining of uranium. The facilities that uranium mining conducted produce tailings that are disposed of in near surface close to the mine. Tailings are the materials left over after separating the gunk of an ore. Uranium tailings poses serious risks to health and the environment. Some of the risks that it possesses are radon emission, windblown dust dispersal, and leaching of contaminant into nearby water sources. Uranium mines also affecting surrounding population. For example, United States left 500 mines abandoned in native Navajo territories. As for the result, the rates of lung cancer and other diseases affecting nearby population rose drastically. Last but not least, the hot wastewater are one of the disadvantages of uranium-fueled nuclear reactor. Most of the uranium-fueled nuclear reactor uses water as it goes through substance to transfer the heat from reactor core to the secondary system and as a coolant for the reactor core. As a result, an abundance of hot water could be produced each day. The hot wastewater then will be disposed to the nearby water source. As uranium-fueled nuclear reactor will be built nearby a river, the hot wastewater will be disposed in it. The life that can be found in the river will be at high risk, as the hot water will increases the temperature of the river that then will surpass the temperature that the aquatic life could survive.
In conclusion, the purpose of this research was to identify comparison between uranium-fueled reactor and thorium-fueled reactor. Based on the analysis conducted, it can be concluded that thorium-fueled reactor were more advantageous than uranium-fueled reactor. Some feel that thorium will be crucial in the development of new generation of nuclear power that is both cleaner and safer. A group of Georgia Institute of Technology scientists appraised thorium-based power in 2011 as, quote, a 1000 or more year solution or a quality low carbon bridge to truly sustainable energy resource addressing a substantial percentage of mankind's negative environmental effect. That's all from us today, and thank you very much. See you again.